Hi guys, so no, the Matrix doesn't have you. This is today's teardown. This is a Raytheon radar receiver. This is the actual part that goes in the boat, and as you can see, this one is slightly unhealthy. This goes with the with the radar head, and I'll put a link down there, up there, or wherever to that. It's taken me a while to get round to this one. This did work when it went in the storeroom, and now we've obviously got loss of sync on one side. Curiously, the way you are looking at it is the way it's designed to be used, but the way the tube is set up is in that direction. So it's vertical sync we've lost. I'm not overly sure why. So we're going to tear into this. This is junk, garbage. There's nothing in here we want. I may keep the CRT because it's a long persistent screen phosphor. They're not easy to get, and I could see it being something that someone might want. But we'll tear into this and we'll see what's in here. I will pause the video now so I can unplug this and let this discharge for a bit, and then we'll tear right into it. Right, so let's get into this thing. So first thing you can obviously see we've got going on in here is the CRT. I'm guessing that's probably going to be a fairly normal composite monitor. It could be something else, but I think it unlikely. Certainly we'll be trying to save this, and I'm hoping that the rolling picture is more to do with the logic board on the back, on the bottom. Turn it over. This side we have nothing, but we have obvious expansion here for something. I don't know what this would be. We've got a connector down here. We've got this here, which that goes off to a port marked C-Talk, so obviously a C-Talk interface card of some kind. Then we have our main logic board under here, which we'll take a quick look at because we know a fair bit about this. So what comes in from the radar head is effectively video, and that the sweep of the radar head provides a sync signal, and that sync signal would be passed into a fairly basic analog setup on an old style radar. The whole thing is locked together, and there's not a terrible amount to it. You can use an analog delay line to hold one complete sweep, and then you can subtract the last sweep from the previous sweep, which will only show you things then that have moved, which is how C clutter and things like that are often dealt with. This is obviously completely digital because we're using a raster display, so this has to digitize the incoming radar data. It then has to do decluttering and all the other features, the chart plotting, etc, etc, that this has. As you can see, there are an array of buttons. All of that has to be done digitally, and then it has to be presented on the screen along with management of the user interface and the various interfaces on the back. We'll have a quick look at those. So we've already ascertained that the C-Talk on the back does nothing. That is a... Sorry, it's just one of those days today. So we've got two fuses. We've got C-Talk, which is a industry standard networking system, and obviously we've ascertained that that doesn't go anywhere. We have RayChart, which is a connection for a chart plotter. FF, not quite sure what that one's going to be, and we have NMEA, which is again industry standard for navigation data. Some of you that have worked with GPSs will be familiar with that, and this provides its own set of NMEA data and consumes it as well. We have the radar head output, and we have power. Not really much on there. So looking at this processor board, there's a fair bit going on here. There's an awful lot of RAM on this, but I guess that kind of makes sense because we need to do the digital equivalent of that delay line. So we've actually managed to identify most of what's on the bottom of here as well, which is quite cool. Normally with lots and lots of specially branded chips on here, you have no chance, but we've got somewhere. Let me just grab a pointy stick, which I am struggling to do. We're going to go with an Allen key today. So starting on the bottom here, we have an awful lot of RAM on this before we go anywhere else. So we've got SRAM here, DRAM here, DRAM here, DRAM here. This I'm pretty sure, because we've got these two ASICs, is going to be used in part of things like echo cancellation, dealing with the rain and sea returns and things like that. This, I'm guessing, is going to be scratch pad RAM for the processor, and then we have the static RAM up here, which I don't think is battery backed, but I don't know if this is set up so it would have a permanent feed or not. We have a UART down there, which is almost certainly dealing with our external interfaces. It would appear that those UART pins go straight to here. I don't think the radar head is intelligent. I think the radar head was fairly dumb. There didn't seem to be any sign of any real microcontroller or anything in there, so we're probably dealing with the radar head in here, and I suspect the D2A is being used to control that. We do have some fairly hefty transistors down there. I believe they are actually transistors. We've got reference voltage down here of some kind as well. This ASIC, as I say, we don't know exactly what it does, but it does talk directly to this chunk of DRAM there. I believe that's DRAM. Let me just check that. That is a 53461, which I think that's actually video RAM, which is strange because we've got a video controller up here. It might just be the easiest way of them doing it. Well, I suppose I'd actually specify it as video RAM, but it's dual port memory, and there's all sorts of things you could use that for. We have our processor up here. We have these bizarre looking ICs up there in packages I've never seen. Don't know they're resistor networks. We have another ASIC here, which is, I'm guessing, the glue logic for everything. This is connected directly to this, which I think is another DRAM. Let's just check the number on that. Oh, it's on the back side there. TC524. Yep, that's just DRAM. So nothing interesting there. We have SRAM here. We have a full-blown graphics controller. Now, I'm slightly curious about the layout because we have a graphics controller up here. It would make sense these 74 series logic chips are tied directly to here, and they're tied to the graphics controller, and our video output is down here, so I'm sure there's a reason for that, and I'm almost definite that that is not involved in video output. There's not really much else of interest on here. We do have battery back there. I think that there is actually more. Yep, that's more memory, so that's battery backed SRAM there. There's EEPROM there. Somebody's already pulled me up on that one. And that's it really under there. It's fairly specialised, but it is a completely contained system. If you could work out what was in that ASIC, then you could probably write your own software for this and repurpose this board, because obviously you've got a fairly good, it's not that video controller is not going to set the world on fire, but it's capable enough. The processor's not blazingly fast, but certainly usable. I don't know what chipset, what instruction set it runs. It's a D878C10. I don't think it's 8085 compatible. It might be, but your problem is going to be working out how the memory maps to everything. But if you knew what you're doing, you could probably disassemble that and find out. And that's a 27C1001, so it's a larger EEPROM as well. So let's pop this board out and see what we've got underneath it. So this is mostly front panel connections here and here. There are a few cable ties which we will need to manage. It is all nicely put together. This large transistor here is glued down. I'm assuming that we've used the zip packages solely because of space constraints. That would make the most sense to me. Everything's cable tied down. I'm surprised there's no conformal coat in here, but the case was sealed on. It looks like we didn't actually need to cut that cable tie. And then if we lift this board out, we can get to these last connectors on the back. And yes, I know you shouldn't pull the wires. We have a connector there to a speaker in the front, and there's the board with a little bit of logic on the bottom. It's conformal cutting on one side. Okay, I'm sure that made sense to somebody. So let's just have a quick look over at that graphics processor, and it would appear, so the graphics processor is tied to the bus by these chips, which not surprisingly are 74HC245s. The RAM is directly on the bus, so this will be generating chip select logic for everything. You could probably talk directly to the graphics controller if you wanted and find some way of doing that. I'd imagine the graphics controller is responsible for generating all its own clocks. Right, so that's fairly boring. There's nothing else there. How do we go further? Trying to work out how to do this without completely destroying the CRT. Let's get this back off. So we've got 2 screws in here. It is lovely and clean in here. There's no real contamination or dirt in here. One there and one there. I would expect these heat sinks to be playing a part somewhere, but I don't see much. They're not moving. There are components attached to the heatsink just down there, so we would need to get that graphics board, that display board out, and I've no idea where we start with that. It is a nice solid chassis, and I do think, looking at it, we are literally going to have to pull every single screw out of this to get in. So we can't get the back off because the screws to take the back off are covered. We can't take that board out and slide it that way because, oh, we might be able to do it that way. Okay, let's try that. I'll try and keep the monitor together. We might have to go back and reassemble the monitor. Should we see what this does? I don't think that helps us at all. I don't think. Oh, there we go. Right. And that's power supply, not the monitor board. Okay, let's just try and separate this some more. There's a choke here, so everything on here is going to be very, very well filtered. And obviously we need to remember that this is providing power to the radar head as well. So we have one wire going over to the monitor. I will bet that's 12 volts to the monitor. And we have separated the 2 halves. Let's have a look at this power supply. Put that over there. So first up, we've got a transformer. So there is switching going on in there, I would imagine. If we look at the bottom, that is definitely a switching transformer of some kind. And we have some we have one test point. Okay, that's not great. This here is going to be the power to the radar head, which I think is going to involve some fairly chunky voltages. And this is our signal connector coming back from the radar head, and you can see the coax there will be the video signal coming back. What else have we got? So these are fuses for that. So we have 2 wires coming up. The white, so the brown appears to be a common, which supplies both fuse holders. The white returns back to the power supply board, and the orange goes up to the radar head. So I would imagine that's 1 fuse for the radar head and 1 fuse for everything else. And just a quick look under there, we're looking at the white as the return. Second pin in, so yeah, that comes through the choke, so that white is the 12 volt feed for everything. The monitor is choked. It appears once again the camera cut out without me realising, so I don't know how much you got and where this cut off, but we've put the buttons out the front, and these are a lot nicer than I thought. I expect a rubber membrane and they're not. So having just struggled to get this back together, we'll peel this off, and half of these are going to stay behind. So you've got rubber buttons, and then underneath you have, I'll take that one off because it's already partially off, you have little transparent plungers that push down. Everything is transparent, and then we have edge lit LEDs under here. So these make sure that you've got a lovely big surface to push on, and then underneath we've got little array of little tactile switches, and I don't even think they're a diode matrix. That is one button per pin, and the LEDs are all driven. I think you've got 2 LEDs in series and then all in parallel. Simple, effective, does the job. Right, let's just go for here because I think this one's going to be slightly more problematic to get into. I don't know if we need to take that one out, but we did need to take that one out. Right, so we've got something funny going on with that D-pad type arrangement at the bottom, but we'll lift this out because this appears to be one unit and turn it over. So it looks like we've got the same arrangement again, and yeah, we've got the little plungers underneath, so that's exactly the same. And then we've got these, I think they are rotary encoders. We'll have a look in a second, with seals around them. Yeah, I don't think they're pots. Seals around them so they can poke through the front, and I'm guessing they will seal to the shaft as well. Yep, they do, and they are indeed rotary encoders. Let's just pull those off. So obviously everything is about being sealed because you don't want seawater getting into this stuff. Let's drop that off the bottom. And I would assume they're rotary encoders. You know what, I'm not 100% sure they are. Well, there's certainly enough pins on that edge connector for it. But yeah, that's... No, they do say RV, so... I'm not sure why there'd be 4 pins though. 4 pins says rotary encoder to me. Maybe we'll put a meter across them and find out. And then we have this D-pad type thing here, and that just leaves the speaker in the front. Right, what I'm curious about here is we have what would appear to be a directional type setup, but we are only taking 4 pins away from here, and we've got an LM324 on the bottom. So my guess is this is some kind of joystick setup, which it is. How would that work? So that is a protected membrane of some kind. So what I'm guessing is we've got 1, 2, 3, 4, 5, 6 quadrants there, and I think, I'm not sure, that we're divided up into 4 sensing quadrants there. So my guess would be this provides an analog voltage that is somehow proportional to the position of that switch. You've got 2 outputs, so maybe one's an X and maybe one's a Y. And it's almost tempting to feed this with some voltage and see what it does. It has absolutely no feedback on it at all. I don't actually like that. Right. Monitor. This is probably not going to be that interesting. So, as you can see... Right, onto the monitor. So what we'll do is we'll just quickly spin the nuts and bolts I put in to keep the CRT under control out. I'm almost certain the problem with this monitor is down to the control board rather than the monitor itself. It would be interesting to know what goes in here because we've got a lot of wires going in here. I'm not quite sure why we would have that. So can we just pull this tube out of the way? Let's just, even though it's only a tiny net board, tiny CRT, I do not trust it. I do not trust CRTs full stop. Come out. I'm pulling the wrong way. There we go. We've got a ground there as well. Come off. There we go. So we'll take that CRT away. That is a lovely little Toshiba CRT. That is an E2871B39 SDHT. We'll have to have a look see what that is. There's the label for you that are looking at it, but it is a lovely little flat screen CRT. That's really nice. I really like that, and it's a nice size as well. Carefully put that over there, and we'll have a look in here. Oh, I found all the controls now. Now we've ripped it to bits, I found the controls. Let's just pop this board out. As I say, I want to try and keep this intact because we might be able to use this monitor. And it looks like, helpfully, a lot of what we need is marked. So it shouldn't take long to work out what we're doing with this. Are we out? Something doesn't feel out. Oh, there's one just for the flyback just down there. This will not be world-shattering or amazing. This will just be a frame monitor. So yeah, that's a nice frame that keeps it all together. So I will keep that. Let's zoom you down. Whee! And that's not something sparking. That's just the label underneath. Yeah, so there's our V-hold, V-linearity, and V-size. Sub-brightness, contrast. So there are all the controls we actually wanted. So we could have tried possibly to have brought everything in. So how well labelled are we? GD, which is ground. Okay, that's not a good start. The power input is not marked. Okay. Tube base has nothing on it other than surge arresters. Everything is so clean. Anyone that's worked on TVs will know how you get muck and crap on the high voltage, and this is absolutely spotless. Wonder if this is the same date. What do we reckon? There's some weird hybrid there. Not interested in that. There is a single chip. That is it. There is one chip on the whole thing, and there is a SIP package down there, an AN chip, which I think are normally Panasonic, and I can't see a date code on that. This isn't conformal coated at all. It's a JRC part up there on that top corner there, which isn't surprising. So there may be information to be had on this, but I don't see a date anywhere. I would imagine it to be the same as everything else. The caps are not the same manufacturers as a power board, but I think those caps are Nichicons. Marum, no, they're not Nichicons. Oh, there's a chip under there. That will be the deflection. Right, so what have we got? So I would expect horizontal sync, vertical sync and video, and we've got one wire too many here. So what have we got? VD, HD, vertical deflection, horizontal deflection, SA, no idea, VS and ground. VS, now VS, we go in and VS goes straight into the contrast pot. So VS, I'm guessing, is possibly our video. I wouldn't expect it to go straight into a pot. SA, straight in through a resistor. I've just spotted something. Straight in through a resistor and into a transistor. So maybe that's video, because that's going to, what's an it's like an amplifier. We've got a burnout here by the looks. So that track there, can we work out what that's carrying? Something fairly heavy. There's a flyback diode there, and I wonder, because it looks initially like corrosion, but it looks like the board is burnt further under. There's no sign of any damage up here. Oh, it's on that cap. That's capacitor juice. So yeah, that looks like we've got a leaky cap that's gone there and has started to damage things. I'm willing to bet if we pull that up, actually I can see it, the board's wet. I don't think I can show you though. So yeah, we've got a duff cap down there, so that would probably need to be replaced for this to work. Yeah, I'm not 100% sure what we would squirt down those lines. They go in on here. We've got two definite signals coming over to them, and they come straight over to this connector. So maybe that's to allow for two different types of monitor, but it looks like the pitting's the same. And then everything comes up here onto here. Up onto there, and then across. So yeah, that's the video signals being moved along there. Yeah, there's not really a lot there that tells us anything, so I don't think that gives us anything helpful. It looks like there are only 3 signals going up there. Without buzzing it out, there's no way to be sure, but yeah, so we'll quickly pop that, well, I'll pop that back together off camera, but hopefully that's a potentially useful little monitor. I don't know what I've got that needs sync and video, but maybe given, depending on what frequency range we've got here, it's something we could try and drive with a micro or something. That would be an interesting job, wouldn't it? What could we do with that? If we drove that with a micro, what could we do? It'd make an interesting clock, wouldn't it? Possibly the world's most power-hungry clock. I think you'll be seeing these two again. Anyway, that's it for now. I'm going to put this back together with that, bolt it all together, make it secure and safe, and then, as I say, maybe you'll see that again soon. Sorry if the video is a bit choppy because the camera cut out, but take care and don't forget to like and subscribe. Take care. Bye.
So, back again, and just popping back in after the fact. I did change that cap. We had a quick look, and it turns out that was the problem. So we put everything back together on the bench and fired it up, and as you can see, everything's happy. Well, as happy as it can be without the radar head. So I'm not sure what to do with this now, because obviously I'd like to do something with this CRT. It's a really nice CRT, but I can't think of any ideas for it. It does appear, having looked with the scope, that it's horizontal sync, vertical sync video, and then it provides a sync pulse back. With older radar sets, this was actually used to synchronise the radar head and the CRT. Don't quite know what they'd be using it for here, unless they're using it for racing the beam, which is always a possibility. Anyway, driving this with something like a micro would be a bit of a pain in the backside. I realise a lot of the work will be done already. But I'm more of the let's see if we can't actually talk to the graphics controller on here. So if anyone's got any ideas, pop it in the comments and maybe we'll see what we can make out of this. Anyway, take care. Bye.